Hello everyone. Having a good conference so far? Welcome and thank you all for coming to my talk, What's in a Model? My name is Asbjørn Ulsberg and I'm a developer experience architect in Swedbank Pay. And let's start off by making an application. This is the UI of the application I'm going to build during this presentation. A simple customer creation UI. A bit too simple, many may say, but I think it provides enough complexity for this talk. And this is the initial architecture, just as simple. We have a browser making a web request to our application, which in turn makes another request to a customer service. If we zoom in on the web application and look at what goes inside there, it's just basic deserialization and serialization. And the same thing goes on the response coming from the customer service. So we start off with a really simple implementation of our backend code with a customer request class that we use both to deserialize the data coming from the browser, as well as the object we pass on to the customer creation service. However, after a while, we discovered that reusing the same object as request data to our backend code, as well as for invoking the customer service, causes some problems. Users aren't just entering pristine, valid data. They enter rubbish, or sometimes don't enter any data at all. And that doesn't go so well with the external service, causing things to blow up and making people unhappy. So we changed our architecture by introducing our own customer model, which we validate before we map it to a customer request object passed to the external service. The response, we just deserialize and map into the same customer model before we return that to the browser. Our backend code now looks a bit more complicated. We perform some validation on the customer model we take in. We map it to a customer request class, pass that to the customer service, and then map the response from that back into a customer model, which we render in the view. The mapping is very simple, just property for property. And this is now how our customer model looks like with validation attributes. And we test the validation and get a great sense of accomplishment as we see the UI completely painted in red. So, now it's thumbs up and we can go home, right? No. We learned that the customer service is returning the phone number with a 0 prefix instead of a plus sign. So we can't just pass the result unmodified back to the browser. We should represent it with a plus sign, so we need to alter it somehow. We need to do some sort of translation inside the map method. So we add some logic to substring the phone number and replace it with a plus sign. Now everything is fine, right? No. Another hitch shows up. The customer service has had a new version deployed that splits the name into first and last name property. Okay, no problem. We'll just concatenate the first and last name into full name field before we construct the customer model. Now then, no. Some business person comes along and says we need to build a mobile app for our fabulous customer interface. We go back to the drawing board and adjust the architecture by introducing an API. But now that we have all these validation and business rules inside the web project, How do you avoid duplicating all of that in the new API project we just created? We create a shared project, of course. And in it, we place the customer model with its validation attributes and some extension methods that we extract from the mapping. So now we have a web project and an API project that both depend on a shared project. Now then, all good? Yes, for now. The problem isn't apparent at first. But after a few months of development, with the addition of more projects, we discovered that the shared project has developed into a mess, with a lot of vaguely named files that no one really knows what does, and a plethora of dependencies that no one can answer for. And if we take a look at what the contents of these files are, we see that a lot of them contain what I would call business logic. And when you think of it, are really extension methods and classes called models, utils, common, mappers, and helpers really where we want our core business rules of the application to be situated in? I think we can agree now that we have a sort of messy application. But how did we get here, and what can we do about it? Let's try to find some of the sources of our problems. I believe our problems stem from at least 3 different sources. We have a certain lack of control. We don't have a clear plan or design or architecture behind everything we do. And we are lazy. Let's first have a look at how we have a certain lack of control. We might have upstream dependencies with classes out of our control. We might have ORMs that dictate how our classes should look like. We might have serialization libraries that put constraints on our classes. And lastly, our understanding of the domain may not be sufficient. So we feel a lack of control over how the business affects our code. ORMs have a tendency to demand things from our classes that are unfavorable. And Hibernate, for instance, requires a default parameterless constructor to exist, and all members need to be virtual. Some serialization libraries requires all properties to have a public setter, and they require us to decorate models quite heavily in order to control how the data looks like when it's serialized on the wire. So, to our domain knowledge. What is a domain exactly? It's missing a word. It's business domain. Adding the word business makes it sound instantly boring, right? A few years ago, I would actually agree with you. But the more you understand about why you actually have a salary and why the company you work in earns a profit, the better applications you can create for that company. And we all take great pride and find it fun and rewarding to create great applications, right? So how do we learn the business domain then? We talk to people. We figure out who the domain's experts are. They may be super users of the application we are developing, or they may be support personnel talking to users that complain about the application we make every day. Or it may be a neighbor developer on your team. It can be anyone, and it can be more than one person, but it's someone who understands how the business works and why it's possible for your business to make money. Learn the language of these experts and use that language within your code. Now on to the plan, or lack thereof. Perhaps no plan is a bit harsh. Let's instead say we might have the wrong plan. The three-tier architecture of the 90s might not be the best way to think about modern development. I'm not saying you shouldn't have different layers in your application. I'm just saying that I believe this top-down perspective gives us the wrong mental model. Data coming from the presentation layer goes through all sorts of validation, while data coming from a database or external service is just passed through without any validation at all. Data coming from the top is considered dangerous, while data coming from the bottom is considered safe. I hope that after this presentation you will agree with me that this mental model is wrong. An important part of the plan is to have a toolbox full of patterns. To know patterns in programming is sort of like knowing formulas and equations in math, or like theories and laws in physics. They allow you to recognize problems when they arise and instinctively knowing what to do about them. The more patterns you know, the better you become at solving problems. Just by giving a certain problem a name, such as the decorator pattern, makes it possible to discuss, search for, read about, and understand in a much better and more unambiguous way than it would have been possible if you didn't know the pattern existed. And if you just plow ahead and write code without any of these patterns in our toolbox, we're going to get into the same kind of trouble a physicist who doesn't know Newton's laws of motion may be. Well, not that bad, but I hope you get my point. Another part of the plan that seems to be wrong is our understanding of these three letters. Don't repeat yourself. Dry, as defined by Andy Hunt and Dave Thomas, says every piece of knowledge must have a single, unambiguous, authoritative representation within a system. And I underscore piece of knowledge here, because dry is not about lines of code itself. Code is cheap and can be copied. Knowledge and business logic may be expensive, complicated, and ultimately what we earn money from. Therefore, it is this business logic that should be made dry, not lines of code itself. Code can actually become too dry, and too dry code causes all sorts of coupling and friction in our development process. So, when in doubt, duplicate. The code you're duplicating may look alike now, but the future will show whether you generally have the same need twice or whether you have two different needs that's just looking the same today. First, when you have copied the code, say 3 times, and every time you make a change to one code piece, you need to make the same change in the other code pieces as well, you know that this most probably is a generic feature worth moving into a shared dependency. Just be aware that creating a shared dependency has a cost. And lastly, why I say we are lazy. We don't question defaults, for one. Please, a show of hands, who has read these 3 letters before and know what they mean? MVC. Yeah, about half. Model View Controller. Right? Please raise your hands again if this is how you organize your web projects. Yeah, a few more. If organization by type is such a good idea, why don't we do it for all our types? Why don't we have all Booleans grouped together, for instance? Please raise your hands again if you think this is a good idea. Another reason I say we're lazy is because we seem to go out of our way to avoid creating a new class. Instead of creating a class that we have full control over and that serves a single purpose well, we reuse existing classes simply because they have the right shape, the right properties. So we end up with classes that instead of serving a single purpose well, serve many purposes equally bad. And this reuse breaks the single responsibility principle of solid. And the solid principles are some of the important patterns that we should know and have in our toolbox and use every day. Model reuse also goes against almost all existing professional advice, such as this quote from Web API legend Mike Amundsen illustrates: "Your data model is not your object model, is not your resource model, is not your message model." My takeaway from that is that for each of the models he mentions, we need a separate class that serves that model well. Okay, so now we know some of the sources of our problems. But what can we do to fix them? I think a big part of the problem can be solved by nurturing a focused core domain model. So what is a domain model? Wikipedia's definition says that in software engineering, a domain model is a conceptual model of the domain that incorporates both behavior and data. And while a domain model can live inside the business logic layer of this drawing, I believe we should look at our application from a different perspective. I also believe we should stop grouping our code by type. Instead, I think we should look at our application as an onion, with a core domain model in the center, and one or more infrastructure and UI layers on top of it. The core domain should consist of classes that represent our business, written in idiomatic C# or whichever language of your choice. And the point is that the core should have no external dependencies. And how you write code within it should only be influenced by the business and its needs, and not by your ORM framework, external services, or serialization library. If you slice the onion up in pieces, each slice represents a feature that have their own core domain model and a namespace grouping every related domain concept together. By grouping by feature and allowing the namespace to flow naturally from the core and out into the infrastructure layers of the application, we can allow namespace scoping to work to our advantage. Instead of having to name anything common or shared and referencing that everywhere throughout the source code, everything one step up the namespace hierarchy is common and shared for the current scope automatically. So, the daemon project, everything inside customers and processing namespace is shared and common. And to the processing project, everything inside the customer's namespace is shared and common. And so goes for the web project. So if we go back to our onion, what we find in the infrastructure and UI layer are things like console applications, web API, external service connectors, database access, and so on. Inside the core, alongside our domain models, we will have so-called ports, or interfaces, as it's called in languages such as C# and Java. And these define behavior that the core can use without knowing how it's implemented. In the infrastructure layer, these ports are implemented by adapters, or called implementations in C# and Java. The dependency is outwards in, meaning the core knows nothing about how these ports are implemented. So if you take a look at a request that comes into our web application, it will go through our core domain before being passed to the external service. And perhaps even more importantly, the result coming back from the external service will go through the same core domain model before being passed out to the client. And this ensures that all data flowing through our application follows the same business rules. They are being upheld no matter where the data is coming from. Even data coming from our very own database will go through the same scrutiny. So, equipped with this knowledge, let's do some remodeling of our application. If we take a look at our customer model, it's currently serving 3 different needs at once. It's a form model, a view model, and a domain model. Let's start by naming it according to its most obvious use, a form model. Now we can create a simplified view model by removing the validation craft. We can also make adjustments that now serve the view, such as changing the birth date into a string, which has the correct presentational format. But most importantly, we can create a customer class inside our core domain that is completely ignorant of form validation and view model needs. We can improve it by adding a constructor, but we need to find a treatment for our primitive obsession. So what is primitive obsession then? This is primitive obsession. It's all these simple types that are great for general representation of basic data structures, but which don't provide much type safety in terms of our mission to write a tightly defined domain model. So let's have a look at a possible completely valid values for each of these primitives. Think about the names of these properties and what they convey. Is a negative quantity really something we want to allow? Wouldn't that mean the customer gets money for the order he sends us and not the other way around? If these are not acceptable values in your domain, then why would we accept them at all? The treatment for primitive obsession is thankfully not that painful. We just introduce proper classes for all of the primitives that don't fully capture the intent of our business rules. The next step is to ensure that state can't be mutated after our class is instantiated by removing all public setters for the properties that are set in the constructor. This ensures immutability and avoids bugs. Some developers object to the things I've suggested here, saying that it makes the construction of the class harder. And to that I have to say, making the construction of the class harder in order to avoid invalid data seeping through the cracks and poisoning our application is actually a design goal. Another argument I've heard is that they lose the neatness of seeing the name of each property they set while constructing the class. But there's nothing stopping you from making all constructor arguments explicit if your language supports it. And ReSharper can even give you a so-called inline parameter hint that does this automatically without changing any lines of code at all. We still have a problem with our class, though. We have what's called an anemic domain model. Now, if we go back to the definition of domain model, it should capture both behavior and the data. And I think we've captured data quite well now with our domain models, but what about the behavior? Where is the behavior? It's inside these classes. Dubiously named classes in the shared project. If you take the zero prefix method, I think we can fit it nicely within our newly created phone number class as an instance method. Our phone number class now becomes a concentration of all phone number related logic in our code base. The constructor performs meaningful validation that works regardless of where the phone number string comes from. Be it a third-party service, from a user through our web application, or from our very own database. We can always trust the phone number to be correct if the phone number class is able to be instantiated. The toString method is overridden to return the phone number verbatim. And if we are really creative, we can even add operator overloads that allow us to treat the phone number class just like a string without losing static typing or strict typing. Lastly, the zero prefix method now lives inside the phone number class where it belongs. If we go back to the find older method we had in the utils class, perhaps we can find a more suitable home for it. Inside the customer class, for instance. If we implement the birth date comparison with the iComparable interface, we get the added benefit that our customer class is now sortable out of the box. And we might even add operator overloads that take advantage of the iComparable implementation. So customer classes can be compared through ordinary less than and greater than comparison. Now, I'm not saying that customer classes in general should be comparable by their birth date. This is just an example. Be creative. Listen to the business and its needs. Just use the programming language of your choice to its full potential. So if you go back to the controller, things now look a bit differently. We now take in a form model, which is mapped into a customer domain model. And if that mapping fails, it's a request error. The mapped customer domain model is sent to the newly defined customer service port or interface inside the core domain project. And the return value is the same customer domain object again, which is mapped into a view model before we return. The form model still looks mostly the same, but now it has a map method that returns a constructor customer class. And we can be sure that it's valid all through the code base. And perhaps more importantly, we managed to turn this into this. The shared project is gone, replaced by a core domain project with no external dependencies and a set of neatly defined domain objects that comply with the solid principles and our business rules. So, some final thoughts. Classes should serve a single purpose. If you reuse classes for more than one purpose, be aware of the compromise you make. It might be worth it, but make an informed decision about it. Extension methods may indicate the lack of a domain model. It may be a code smell. They are great for classes and objects you don't control, but be aware every time you create an extension method whether it's the right solution to the given problem. Write idiomatic code in your domain model. Don't allow dependencies to dictate how you write code inside the core domain. Treat your primitive obsession. Create classes for all concepts that aren't fully captured by existing types. Avoid anemic domain models. Ensure that your domain models have both data and behavior. And think about your namespace hierarchy. It should flow from the core through the layers of the application, each layer adding a part to the namespace, so everything before it becomes within its scope. And just a little tip on namespaces. I recommend you use gerunds as the name of namespaces. That's a difficult word meaning verb nouns, meaning you should use authorization instead of authorize as namespace names, authentication instead of authenticate, processing instead of process, and so on. And this is to help ensure that you avoid collisions between namespaces and classes. So just a little tip there. Explore your domain with a domain expert. Realize that not all fun in development needs to come from technical challenges. If you see no challenges or fun in your business, the chances are high that you are inventing technical and accidental complexity instead of solving real business needs. What I've talked about here today is basically just what I consider best practices for object-oriented programming. But I want to go so far as to say, if you don't do any of the things I suggest in this talk, maybe you aren't writing object-oriented programs at all. Maybe your style of programming is procedural. And there's nothing wrong with procedural programming, but one has to wonder why, if that's the case, you're using another object-oriented language and not instead something like Fortran or COBOL. Writing in procedural languages, after all, is much more profitable than object-oriented programming. Just a thought. If you want to know more about what I've talked about today, Jimmy Bogart has a great talk called Solid Architecture in Slices, Not Layers, where he discusses many of the same things I do here today. And Einar Høst has a fantastic talk about modeling called Technical That Isn't Technical that I can warmly recommend. And Dan Berg Jonsson and Daniel Dögen has a great talk called Your Business is Under Attack. Arm yourself with domain-driven security. And in that talk they show how not doing domain-driven design may lead to security breaches in your application. And lastly, here are some of the words and Slack URLs I recommend you explore after this talk. And please don't be afraid to reach out to me on Twitter, Slack, or wherever you see and find me for questions and comments. Thank you.